Now, last week I thought I was done with rejuvenation, but we are back for even more, and I mean that literally for the video, but also for the research paper we will take a look at where they do more than once expression of these yamanaka cellular reprogramming factors.
Whoa! Woo! Yeah! Who's up for round 2?
At different onset times and for varying extents in physiologically aging mice. But is it causing rejuvenation? And what do the results say? Well, we'll take a look in this video. Now, if this is the first video of mine that you've ever watched, then hello, welcome to the Sheekey Science Show. But maybe you should watch this video or this one first, because I'm pretty much just going to cut straight to the chase this time. Because in this paper, they were evaluating longer-term partial reprogramming in normal mice. Imagine I just did that normal in quotation marks. And by partial reprogramming in this context, it means expressing the reprogramming factors, otherwise known as the yamanaka factors, for a short time period, with periods where they're not expressed. So the cell will start to reprogram, but the idea is it doesn't enable them to completely refast to a stem cell and lose their identity. At least that's the idea. So how did they perform partial reprogramming in this study? Well, let's take a look at the different treatment regimens that they did. Who've we got? Well, they tested both long-term and short-term partial reprogramming strategies. There were 2 different long-term treatment regimens, 7 and 10 months, starting at 15 and 12 months of age, and 1 late-onset short-term treatment, so only 1 month for reprogramming starting at 25 months of age. And then how did they do it? Well, they used genetically modified mice, whereby the yamanaka factors are expressed after being treated with doxycycline, which enables the expression of these genes. And for the partial aspect, they give mice doxycycline for 2 days and then 5 days without it. So it's interesting to note at this point that this differs from what we looked at last week, where the mice were given doxycycline for 7 days, albeit in that paper, it was only those 7 days that they did it. Okay, so different. And actually, interestingly, the doxycycline levels that they used also differed, but they're different papers done in different labs, and they're not doing the same thing. But they were both interested in looking at the same outcomes. Is there rejuvenation? Well, in this paper, they assessed the mice and took different tissue samples after the interventions and looked at molecular markers such as DNA methylation, gene expression changes, metabolomics, and histology. So, what did they see? Well, the only intervention that seemed to show more consistent changes were the long-term protocols, so I'm not really going to focus on the short-term ones here. And firstly, they looked at DNA methylation, a marker that is thought to track with age. They see in the long-term treatment regimens a reduction in epigenetic age in the kidney and liver, but it is worth pointing out that they used a new type of epigenetic clock, the lifespan Uber correlation, which I frankly don't know much about, and that the results using this clock were better than the traditional methods. So potentially not the most valid data set. Plus there wasn't many mice in this part of the paper. So maybe there's something going on with the epigenetics, but what about the gene expression? Well, in the skin, where they saw some changes in DNA methylation, they also saw some changes in gene expression, and saw a reduction in genes associated with senescence and inflammation. But gene expression is not a great indication of senescence, so what about the metabolite changes? Well, at the end of the 22 months, there were some differences between mice that did and didn't have partial reprogramming. One metabolite that stood out for me was 2-hydroxyisocaprylic acid, but it wasn't clear what the trend was with age. Is it supposed to be going up or down? There just seemed to be a difference after this reprogramming. Anyway, what does this all mean? Well, like last week, this seems to be more of a mechanistic paper than a functional one. And it seems an important takeaway is that whatever they were doing to the mice was well tolerated, but without lifespan data, it's hard to say if any of these changes that we can see with this partial reprogramming strategies is actually causing any rejuvenation in the aging process. And at least from my opinion, based on the strategy that they were doing, maybe this partial reprogramming was maybe a bit too partial, as there weren't, many great changes in the mice. And so these past few weeks now, I've truly gone down a rejuvenation rabbit hole, and I don't think we've escaped yet. because I will definitely be back next week with another rejuvenation video. But anyway, another thing you have to remember about is that this study was done on mice, and we are not mice. And I guess the other interesting question is, how do we ever translate these different genetically modified mice protocols into human therapeutics? And on that bombshell, I hope you learned something in this video. Thank you to my Patreon supporters, and thank you for listening.